In this question it is given that the linear velocity of a rotating body is given by v is equal to omega into r, where omega is angular velocity, r is the radius vector. The angular velocity of body is given and the radius vector is also given. Our aim is to find out the value of magnitude of velocity. So it is given that velocity is equal to omega vector cross r vector. So first we can find out what about the value of omega cross r. So we can write, if you want to find out the value of omega cross r, we are going to find out it by using determinant method. We can write as I, j, k. Then we can write the component of omega over here, that is 1, minus 2 and plus 2. Then we can write the component of r over here, that is 4 minus 3, and its x component is 0. So we can write as 0 and 4 y component and minus 3 as a z component. Now we can find out the cross product of these two vectors. So we can write in format I cap. Now if you are taking I cap, we have to eliminate this column and row. Then we need to multiply in this direction. Minus 2 into minus 3, which is 6. So we can write this as 6 minus 4 into 2, that is 8. Minus j cap into. Now we can eliminate this row and column. So we can write, we need to multiply this 1 and minus 3. So this 1 and minus 3, it is minus 3 minus this 2 and 0, 2 into 0, it is equal to 0. Plus k cap into. Now if you are taking this k, we'll eliminate this column and row. So we can write 1 into 4, that is 4 minus 0 into minus 2, that is 0. So we can write this is equal to minus 2 I cap. And over here this is plus 3 j cap and plus 4 k cap. So this is nothing but our velocity vector v vector. Now in question they are asking to find out what about the magnitude of this vector. So we can write magnitude is equal to under root of x component square, that is minus 2 square 4, plus y component square, that is 9, plus z component square, that is 16. So you can write 16 plus 9, that is 25, 25 plus 4, that is equal to 29. So you can write this should be equal to root of 29.